DC motor. Please remember, in a few lessons, there's going to be something else called AC generator, right? What does DC stand for? And AC? And if we got our power supply, how do we recognize them, Amir?
So the yellow one is AC, the blue and red is...
Good, correct, very good. Okay, so we're going to be using that. So the little motor, I think we've already done that in the past, and you're going to see what happens inside. Yeah? Hair dryer, just imagine all your electrical devices that they've got, they all use a motor. So very, very important thing, device to sort of know how it works. So in order to understand the DC motor, right, it's called the DC motor for a reason, because it uses the motor effect. So we know how we had the current carrying wire in a magnetic explosive force. You saw it was moving one way, which we can predict using Fleming's left-hand rule. The moment that in our last lesson, remember, we swapped the current, what happened to it? It went the other way. Yeah? The same here. So I want you to observe, right? I'm going to try and do red for positive conventional flow. So what you've got here, the first thing I'd like you to look at, just the wires. So electricity comes in through the red, makes contact here. The wires are connected, as you can see. Yeah, the wires are connected. So there's a side which is going up, and there's a side that's going down. Right? So that's your current carrying wire, which got its own magnetic fields. And then just on the side here, can you see the two magnets? Right? These two magnets are these two magnets. The wire is this wire. And once we send electricity through it, guess what's going to happen? Two fields are going to interact, giving you a force given by FBI, right? However, one is going up, one is going down. So what we're going to have? What we call a couple, a turning force, one way, with the other one the other way. So this will spin. You're going to see it. Well, let's just turn it on. You're going to see it anyway. Not very safe, but I'm just going to try and touch it so that... There you go. So that works. The contact needs to be... Obviously, it needs to make a full circuit, right? You see that works. Now, we've got a problem. Imagine that the coil are spinning. What was going to happen? The wires are just going to get tangled, aren't they? So what do we need? We need the split ring commutator. So you see that little copper here? Right in the middle here, when the coil is actually this way, flat, you have got a gap. If there's a gap in a circuit, what happens? The circuit is incomplete. Is there going to be current? No. Oh my goodness. So your motor is going to stop, isn't it? But did it stop? No. Why? Isman. But it didn't stop. Why didn't it stop? It was already moving. It had momentum. So momentum allows it to continue to the other side. Yeah? And so what I want to show to you now, Musa, spins very nicely. Lower the voltage. It spins very, very slowly. So, yeah, that's around 3 volts. Make that to around 5 volts. Much faster. I don't leave it for too long. But the thing that to understand here now is what would happen if I reverse the current. Jonathan, what will happen to that? It will go the other way. And if I was to ask you to prove that, what would you need to do? Oh, Fleming's left hand rule, because that's the direction of the force. Yeah, Fleming's